story starts with a bang, an explosion of light, a release of an immense amount of energy, the supernova. It's what happens when a massive star spectacularly dies. All massive stars are destined for this path. After the star goes supernova, two things can happen. One, it can pull objects towards itself as it collapses, forming an accretion disk. This becomes a black hole with a singularity at its center. The other, less violent path is the formation of a tiny, extremely dense neutron star. This second path is what we will be focusing on today. Welcome to the Crab Nebula. At its center, the Crab Pulsar.
Neutron stars are extremely dense. Imagine fitting a mass 1.4 times that of the Sun into an area the size of Manhattan.
They are so dense that a piece of one about the size of a sugar cube would contain within it the entire mass of the human population.
A special type of neutron star is known as a pulsar. Pulsars rotate extremely quickly. They also spew radio waves and in many cases X-rays out of their poles in short, powerful bursts. Today we are going to be discussing a very specific pulsar. The Crab Pulsar, formed from a supernova about 964 years ago in 1054 CE. Like many neutron stars, it will probably remain in that stage for tens of thousands of years to come.
It's gonna die out eventually. A long time. Definitely lasted longer than my happiness.
And it's incredibly hot, around 1.6 million Kelvin. The extreme heat makes the star a bright hot white.
It's very ostensibly a Class O star.
It's a really powerful tiny boy.
It's the power source for the Crab Nebula, 7,175 light years away from Earth.
It actually lights up its entire nebula, but you'll need the Hubble telescope if you want to see the actual star.
Like many pulsars, the Crab Pulsar spews X-rays in powerful bursts. Often, instruments in space and here on Earth are able to pick up these X-rays.
Its rotation speed is unbelievably fast. It rotates approximately once every 33 milliseconds.
Combine the rotation speed with the intense magnetic field, and you get a dangerous, but also incredibly interesting object. Just how powerful is this magnetic field, you ask? Think of it this way. Earth's magnetic field is defined as 1 Gauss. Our most powerful MRIs operate at about 10,000 Gauss. The magnetic field of your average neutron star, 1 trillion Gauss.
Some other known pulsars include PSR J0373-3039, the only known double pulsar, Hulse-Taylor binary pulsar, Calvera, Geminga, and Hercules X1.
There are many other neutron stars in our universe. Another less common type of neutron star is called a magnetar, and it is one of the most dangerous objects in the universe. Its magnetic field gets up to 1 quadrillion Gauss. That is strong enough to stretch an individual atoms like spaghetti.
In conclusion, neutron stars are some of the most interesting objects in the universe. They have unique and strange properties. Born out of the fires of massive supernovae, they are the phoenixes of the universe. They rise from the ashes of the massive stars.